Hello again, this is Jack the Exam Guy. We're going to be talking about calculating excavations today. Um, a rectangular type of excavation is going to be very easy to try to calculate. We all know length times width times depth is going to be the volume of a rectangular calculation, or maybe you're doing a driveway, or maybe you're doing, some type of a slab or something, and it's pretty straightforward. Unfortunately, when you're doing excavations, we have to consider the fact that the sides are sloped. Okay, so you're going to have a different dimension at the bottom of the excavation than you do at the top of the excavation. And so that makes it a much more challenging type of equation. All right. So in order to demonstrate that, if you do have your Principles and Practices of Commercial Construction book with you, you can go to page 76 and 77 and 78. There's 3 pages where they discuss this. And if you don't have it, that's fine too. You can just follow along with the slide. So as you see, this is the diagram that they have there, and they call this the average end area method. That what I'm going to talk about. There's actually 3 different ways to calculate this. Okay, if you go to page 76, they've got a formula which is going to be almost impossible to remember. Okay. Now, if you're taking the general builder or residential, you can't take this book in. There are no exams that I know of there where you can take this book in. So, you're going to have to memorize a way to do this. You're going to have to know a way to do this. And if you can memorize that formula on page 76, well, my hat's off to you. You're probably going to be able to pass this exam with my help, without my help anyway. But I would say, since I can't memorize that that formula as many times as I've gone through this book and looked at that, then my guess is going to be you're going to need, like me, a more common sense way to calculate this. Okay, and there is a very common sense way, and they actually explain that on page 77 there. Okay, and if you'll read there, it'll talk about something they call the average end area method. Okay, so I'm going to use my pointer a little bit. So what they're going to do, the end area, they're calling it, is the bottom is one area, one end. The bottom is one end, so that's your 18 by 8. Your top is another end. Okay, so that's 20 by 30. So we know that either one of these would be width times length, width times length, but neither one of those is going to really help us out, because if we did the top of the pit, it'd be too big. Obviously, if we did the bottom of the pit, it'd be too small. The number would be too small. So what we are doing is we're finding the average end area, okay? And then once we get our average area, then we just multiply times our depth. Hopefully that makes sense to you. This is kind of a common sense way to do it. Okay, take the area of the top and the area of the bottom, divide it by 2. Um, that's going to be our average end area, and then we multiply that times our depth, and that'll give us our volume. Kind of an interesting common sense way to do this. Now there is another way to do it. Okay, and if you flip over to the next page on 78 and 79, if you can remember the formulas for all those different shapes right there, then you might be able to get an exact number. Okay, but guess what? If you're human like me, you're going to use the average end area method. Okay, so here we go. So we're going to just do the example they have in the book. So this is the formula which basically explains everything that I talked about. You have their volume equals the area 1 plus area 2, A2 plus A1 plus A2, the top and the bottom area. We're going to divide it by 2 to get the average, and we're going to multiply it times the depth. Okay, and they show you that on the bottom left on page 77. Okay, so here we go. We're gonna work it all out. We got the 8 by 18, and we add to 20 by 30. We divide it by 2 times 12. 144 is 8 by 18, 20 by 3600. Add those together, 744 divided by 2 times 12, 372 times 12, 4464 cubic feet. Now, if you'll look in the book, that's what they got, 4,464 cubic feet. Now, the one thing they didn't do is they didn't convert it to cubic yards, and I don't really like that because you're always going to be asked for excavations in cubic yards. Okay, dirt and concrete are sold in cubic yards, or transported in cubic yards, or dug out in cubic yards, whatever. The unit is usually cubic yards. So what we did is I went ahead and divided 4464 by 27, and it's 165.33 cubic yards. So anyway, now here's the thing. When you get this number, more than likely, you'll just go to your answer, and that number will be there, or a very close number will be there, and you'll say, boom, that's our answer. Now, if there is any doubt about the answer being correct, I want you to remember, and it tells us this in the book, it doesn't say 5%, but I've done calculations, and I can tell you that this number ends up being just a fuzz high. It's about 5% high. So we're not going to worry about the 5% unless the answers, there's two answers really close to each other, and we're thinking the 5% might matter in our choice. So it is about 5% high. That's probably the one disadvantage to this method. But considering the other two methods and how hard it's going to be to try to remember those formulas, I would just, this is the way you want to go for sure. And then there is, by the way, they don't talk about this in the book, but there's also the possibility of a swell factor. Well, they do talk about it, but I don't think they actually do it. They don't add it into your calculation. They talk about it on the bottom left on page 76. There is a soil swell percentage. Now, I cannot imagine that you're going to have to memorize this table. They will probably tell you in the exam what your swell is. But all that means, if it's a 10% swell, you just add 10%. Or, plus 10, hit the percent key, or you can multiply it times 1.1, whatever your favorite way is of adding 10%. And I want to caution you, if you're using a Casio calculator, do not use the percent sign. Okay, that's just a little side note there. Every now and then I'll see somebody with a Casio calculator in a class, and it's baffled me up until recently, and I finally looked it up and saw what the reason was. There's a valid reason, but there's no reason to really go into it here. Okay, so let's try. Okay, here's a typical kind of question. Calculate the volume of fill of a pit with bottom dimensions of 30 by 50 and 10 feet deep. It is in type B soil and expected to swell 20%. Now, so the type B soil means you're going to have to see OSHA regulations for type B soil sloping requirements. Okay, so we can do this one of two ways. You can go ahead and hit the pause button and see if you think you can do it. That'd be great if you can. If not, I'll help walk you through one. Okay, so here we go. So I've got a little diagram to kind of help us out here. Okay, so it's 30 by 50 at the bottom of the pit. Okay, and then you've got, since it's 10 feet deep, okay, you're going to need to slope it 10 feet out. All right, it's 1 to 1. If you went to the table B1 in excavations, that is in the appendix of the subpart P in the OSHA manual, Appendix B, table B1, there is a table which tells you type B soil, okay, is sloped at 1 to 1. Okay, hopefully you watched the video which explains all that, but if you didn't, it's right there on that table. Okay, so it's a 1 to 1 slope, right? So this is 30 and this is 50, so we have the bottom of the uh, pit. But then, and so that's going to be real easy to figure, but now we need to know what is the dimension of the top of the pit. Okay, now remember, we've got to add 10 feet here, and 10 feet here, and 10 feet here, and 10 feet there. So this is where a lot of people make a mistake. They just add 10. You got to add 20 to each dimension, okay, for the top. Okay, so it's 50 times 70 is the top. And then it's just a matter of crunching some numbers, and it's 10 feet deep. Okay, so let's see how we. So here we go. We have the bottom, which is 30 by 50, 1,500 square feet. We have the top, 50 by 70, which is 3,500 square feet. Right? We add them together, 5,000 square feet. We divide by 2. We get 2,500 square feet is our average end area. That's what we're looking for. We're looking for our average end area. That's to start with anyway. It's not the final product, but that's the number we're getting for our average length times width. And then we multiply it times our depth, which is 10, so we get 25,000 cubic feet. 25,000 divided by 27 equals 926 cubic yards. And then we had a swell factor of 20%. So 926 plus 20% equaled 1,111.2 cubic yards of swell. Isn't that swell? Well, this is how you do it. Okay, hopefully you were able to follow that okay. We'll have some practice questions for you at some point. Until then, this is Jack Sheffield, Jack the exam guy. Thank you so much for your business. We appreciate you listening, and we'll see you soon.